Hello everybody, in this video we're going to review systems of linear equations. I'm going to do a video for this lesson just to walk through the step-by-step since it's a little more complicated than our other algebra reviews. So first off, a system of linear equations is two or more linear equations that we are trying to solve at the same time. Okay, so in this video we're just going to be solving for two variables, x and y or whatever they may be. Okay, and the first way we're going to do that is to solve by graphing, and this is really going to get us to see what we are actually solving for when we're solving a system. Okay, so if I want to solve by graphing, first off we got to get these into slope-intercept form. If you remember, slope-intercept form is y equals mx plus b. So what we're going to do is take each of these and we're going to solve each of them for y. We got to put them into slope-intercept form. So I'm going to subtract x from both sides, and then I'm going to divide everything by -3. And that's going to leave me y equals 1/3 x plus 3. Now, if I wanted to graph that equation, this is my slope-intercept, or this is in slope-intercept form. The b, that's the y-intercept. That's where we start. The m, that's how we move. That's our slope, rise over run. Remember, slope is rise over run. So I'm going to start this at 1, 2, 3, y-intercept of 3. And then my rise over run, I'm going to go up 1 over 3 to the right, up 1 over 3 to the right, up 1 over 3 to the right. I could also go down 1 to the left 3, down 1 to the left 3, so on and so forth. I'm going to make a nice little line here. And that is the graph of that line. Now we have to do, our other line is 2x plus y equals 10. So I'm going to do the same thing. I'm going to solve for y here. And all I need to do there is subtract 2x from both sides. Okay, so I get y equals -2x plus 10. Y-intercept is 10, so I'm going to start up here, and I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And there you'll see there's an intersection point right here. That intersection point is the solution to this system. Okay, so the solution, coordinate pair, so I need to put in parentheses. The coordinates of that are 3, 4. Okay, so that is what we're doing when we are solving a system of equations by graphing, or just in general, we're trying to figure out what are the coordinates of the point where those lines intersect. All right, but it is a little bit of work to solve by graphing. So we have two different algebraic methods to help us solve these systems. The first is substitution, where we are going to substitute one equation into the other. All right, and the easiest way to do substitution is to look at your two equations and see which one of those has a variable that's either by itself or can quickly become by itself. So we got 6x plus 6y equals -6. That's going to take a lot of steps to get a y by itself, or an x. But in the second equation, 5x plus y equals -13, this y is so close to being by itself. So I'm going to rewrite that equation and solve for y. So I get y equals -5x minus 13. What I'm going to do now is I'm going to substitute -5x minus 13. I'm going to substitute that in every time I see a y in my other equation. Because y equals -5x minus 13. Y and -5x minus 13, since they're equal, they're the same thing. I can swap them out. All right, so looking at my top equation, I've got 6x plus 6, but instead of y, I'm going to substitute in -5x minus 13. And that's going to equal -6. Now we have a linear equation in one variable. We can solve this just for x right now. All right, so I'm going to 6x. I'm going to use the distributive property. 6 times -13 is going to give me -78 equals -6. And from here, I'm just going to combine like terms, get the variables on one side and the constants on another. Finalize this by dividing both sides by -24, and I get x is equal to -3. So with our solution, we know the x-coordinate is -3. We have to figure out what the y-coordinate is now. So we could plug it back into either of our equations to solve for y. In the top equation, we could substitute -3 back in for x, because that's what we just solved for. And we could solve this for y. And if I solve this now for y, I would get y to be 2. And let's just double check to see, does that work in our second equation? And I can use either 5x plus y equals -13, or I could use the rearrangement that I found. And using the rearrangement might actually be a little bit easier for us. So y equals -5. I'm going to plug in -3 for x. I'm going to subtract 13. So that's 15 minus 13. That equals 2. That checks out. So the solution to this system of equations is the coordinate -3, 2. Okay? And then the last algebraic method is called elimination. And this is where we actually eliminate a variable. And the way we're going to do that is we are going to modify one or both of the equations so that either the x's or the y's can eliminate each other. So, for example, if we wanted to eliminate the x's, we see that the first coefficient in that first equation is -4. And in the second one, there's a -1 here, okay? So what number do -4 and -1 both go into? They both go into 4, okay? So if I can somehow get one of them to become -4 and one of them to become +4, I can now eliminate the x's by combining my two linear equations. Okay, we already see that the top equation is -4. So in order to make the bottom equation become +4, I'm going to multiply the entire bottom equation by -4. So the top equation stays just as it is. I'm not modifying that one. And the bottom equation, after I distribute that -4, it's going to become 4x minus 20y equals 52, +52. Now, if I were to combine these equations, my x's are going to eliminate each other. That's what I'm asking for. That's what I'm trying to do. And now if I add down -15y plus -20y, that's -35y. And then -17 plus 52, that's going to become 35. So y is going to equal -1. All right. In order to figure out what x would equal, I would plug it back into either the top equation or the bottom equation. Remember, it does not matter which one. You should get the same answer as long as your first step here with the elimination was correct. So I'm going to plug it back into the first equation. I'm going to plug -1 back in for y. And I'm going to solve this for... I'm going to solve this for x. So I get -4x equals -32. If I divide both sides by -4, I should get x to be 8. So the solution here should be 8, because the x comes first, 8, -1. All right. Now, let's go back to this real quick and say, okay, what if we wanted to eliminate the y's? So let's start back with our original problem. Equals -13. Okay. Let's say we wanted to eliminate the y's. So we see one's a negative, one's a positive, so that's a good step. Now, what do 15 and 5 both go into? Well, they both go into 15. So I can leave the top equation as is, -15y, and I need to ask myself, how can I modify this bottom equation so that it becomes the opposite of -15y? I need this to become +15y on the bottom. Well, what do I multiply 5 by in order to become 15? I multiply that by 3. So the top equation is going to stay just as is, and the bottom equation is going to become -3x plus 15y equals -39. If I add these together, the y's are going to eliminate, and I'm going to get negative 7x equals, if I add negative 13 plus negative 39, negative 56. If I divide both sides by negative 7, I'm going to get x equals 8, which is exactly what we got here. And then if I plug that 8 back into either the top equation or the bottom equation and solve for y, I better get negative 1. All right, so that is a recap on solving systems of equations by graphing, which shows us the point where they intersect, and then our two algebraic methods, substitution or elimination. Okay, let me know if you have any questions.